video, we'll learn how to assign oxidation states. Not all redox reactions involve charged ions. Sometimes we only see neutral compounds in a chemical equation. To help us track which elements are being oxidized or reduced and how many electrons are being transferred, we assign oxidation numbers, also called oxidation states, to all reactants and products. For this class, we'll focus only on pure elements and ionic compounds. In our context, oxidation states will be equal to the charge of the atom or ion. When assigning oxidation states, it's important to consider the overall charge. If we're looking at a single element with no charge written, it's neutral, and its oxidation state is 0. For a single atom ion, whether it's a cation or an anion, the charge of the ion is the oxidation state. If we're analyzing an ionic compound composed of multiple ions, the total charge of the compound must be 0. We split the compound into its cation and anion parts to determine the individual oxidation states. In this case, we'll only be working with simple redox reactions, so you won't need to assign oxidation states for molecular, also known as covalent compounds. Here's an example of a redox reaction that is also a combination reaction. Iron metal reacts with chlorine gas to form iron 3 chloride. Starting with the reactants, the iron is a pure element, not bonded to anything, and no charge is shown. Its oxidation state is 0. Chlorine, a diatomic element, Cl2, consists of 2 chlorine atoms bonded together. Since it's a nonpolar covalent bond, the electrons are shared equally. Each chlorine atom has 7 valence electrons, just like a neutral chlorine atom. So its oxidation state of Cl2 is also 0. Pure elements, whether monatomic or diatomic, always have an oxidation state of 0. Now on the product side, we have iron bonded to chlorine in an ionic compound. To assign oxidation states, we break this down into ions. Chlorine, a halogen in group 17, gains 1 electron and has a common ion charge of -1. Since there are 3 chloride ions at -1 each, the total negative charge is -3. To balance this, the iron must have a +3 charge. Therefore, the oxidation state of iron in FeCl3 is +3. Let's try a practice problem. If you want to work through it on your own, this is a good time to pause the video. First, we have P4, a pure element. There's no charge, so its oxidation state is 0. Next, K2O is an ionic compound. Oxygen typically has a 2- charge, and potassium is a +1 cation. Then we have NaCl, another ionic compound. Chlorine is -1 and sodium is +1. Fe is a pure element with no charge shown. Its oxidation state is 0. If you see a charge like +2+ in the upper right corner, that would indicate an oxidation state of +2. Lastly, O2, a diatomic neutral molecule with no charge written. Both oxygen atoms have an oxidation state of 0. Let's visit the earlier reaction where iron metal reacts with chlorine gas to form iron 3 chloride. By comparing the oxidation states of each element on the reactant and product sides, we can identify what's being oxidized and what's being reduced. Iron starts with an oxidation state of 0 and becomes +3 in the product. This is an increase in the oxidation state, so iron is undergoing oxidation. Chlorine starts at 0 and ends at -1. Its oxidation state decreases, meaning it undergoes reduction. Remember, Oxidation is an increase in the oxidation state, and reduction is a decrease. Here's another practice problem. Feel free to pause the video and try it for yourself. K2O decomposes into elemental potassium and oxygen gas. Remember that coefficients in front of chemical formulas don't affect the oxidation states, so we can ignore them here. From earlier, we know that potassium in K2O is +1 and oxygen is -2. In the products, potassium is in its elemental form with no charge, so its oxidation state is 0. Oxygen appears as O2, a neutral diatomic molecule, so its oxidation state is also 0. Now let's analyze the changes. Potassium goes from +1 to 0. This is a decrease in oxidation state, so potassium is undergoing reduction. Oxygen goes from -2 to 0, which is an increase in oxidation state, meaning oxygen is undergoing oxidation. One more practice problem. Sodium reacts with iron 2 chloride to produce sodium chloride and iron metal. On the reactant side, sodium is a pure element, so its oxidation state is 0. Iron is bonded to chlorine in an ionic compound. Chlorine has a common oxidation state of -1. Since this is iron 2 chloride, iron has an oxidation state of +2. On the product side, sodium is now in an ionic compound, NaCl. In NaCl, sodium has a +1 oxidation state and chlorine remains -1. Iron is now in its elemental form, not bonded to anything. Its oxidation state is 0. Now let's analyze the changes. Sodium goes from 0 to +1. Its oxidation state increases, so sodium is undergoing oxidation. Iron goes from +2 to 0. Its oxidation state decreases, so iron is undergoing reduction. Chlorine remains -1 before and after the reaction, so it's not undergoing oxidation or reduction.